Alright, we're getting ready to do our Acme thread, so we need a total length from the end of that thread to where it meets that 3/4 inch diameter there, so basically the whole length of the thread needs to be 3 inches 3 inches 925 thousandths from one end to the other. So that includes a little relief at the end. So what we're going to do is we're going to come up here and just put my parting tool, line that up with the edge. And I'm going to use my carriage mounted indicator to measure it because it's pretty accurate and pretty easy. So I'm going to start there. So there's 1 inch. There's 2 inches. There's 3 inches. 925 thousandths. So right there. So now what I'm going to do is I'm going to come in here and make 2 grooves to a depth of 380 thousandths. That's the largest minor diameter by my chart that I can get on an Acme thread. So I'm going to touch. There's 400, 390, 380. So we're gonna do that again here. And there we go. So now what we're going to do is we are going to thread. So we have our Acme threading tool already made up. Okay, so now I got my threading tool in there. This is an Acme threading tool, and it's ground at a 29-degree angle, and this was ground on the machine so that way this threading tool is straight with the side. So in other words, I don't have to go crazy with trying to get this lined up perpendicular to the workpiece. It already is. So we got a 10 TPI, so you can see that this edge here fits in the notch. All right, and we're going to be doing a left-hand thread, meaning that we have to start here and work our way towards the tailstock. Also, since this being a 29-degree angle, we need to set the compound at 14.5. I don't want to thread straight in, especially with an Acme thread, because it's going to take a decent bite, and I don't want to do that. So what we're going to do is just zoom in a hair, and we're going to start, and just like normal threading, but we're going to be threading in the opposite direction. So I'm going to slow this machine down here, and I'm going to set 10 threads per inch on our gearbox. It's 10. Okay, I'm going to come in, come in again, just touch, set 0, and we're going to set 0 on our cross slide here and our compound, and I'm only going to feed in a little bit. There we go. Now we can come and and we are 10 threads per inch. Okay, so now we can continue doing what we gotta do. There we go. Okay, so now that that fits, what we're going to do is we are going to part this off right about there. So that gives me about 3/4 of an inch to sink into the other half. I might need to trim it, but we're definitely going to have to turn it down. But either way, we're going to part it off right there. So let's lock down the carriage. Okay, so now we need to decide what we need to turn this down to be able to fit on the existing screw. As I said, the existing screw is about 400 thousandths in diameter. I actually have a 13/64 end mill, so this is 203 thousandths. So what I'm going to do is turn this down to 203 thousandths, and then we are going to use this like a reamer and put out the shaft of the other one. So now from this end here we need 600 thousandths. Right now this is can't get my stuff in there. So what we can do here is cheat. use this up against this shoulder here, and $790,000. So we are at three inches, 927 thousandths, right in the neighborhood of where we need to be. So now we need to basically break our lathe. So this is the original screw, and I'm going to see if this collet can squeeze down enough to grab this. I don't think it can, and it doesn't look like it can. Let me see if I have something that I can grab this. Okay, so it looks like this collet can expand enough to get it, I think. Yeah, we can get this. We can get this. Alright, we got it. We're running pretty true, and what we're going to do is we are going to basically just cut that off. So we can do that with the parting tool relatively simply. Okay, we are done there. Okay, so now we need to find the center of this, and it's kind of a pain in the butt to find the center of a round piece because you don't know where you are in relation to the actual radius. So what we're going to do is, since we know that this is in the center of the collet block's in the center of the vise, we're going to center find this inside edge, these two inside edges. That'll give us in line this way. Then we can center find this side and this side because we know we're on center there, and then we can have that reading and get center in the other axis. So let's go ahead and turn the mill on here. Okay. Okay, so now we can have that reading. Now, I'm going to come in here. Okay, so we got our end mill in there. I'm bringing it down a little bit. Right to about that. Lock the quill down, start her up, and we're going to use the knee to raise up. I'm going to put a hole that's 600 thousandths deep in there. Call that 0. Okay, so here it is. It fits in there nice. We're going to Loctite this in place, and we'll be back once that dries. So I got this Loctited in place, and I also put a spring pin in there. So this is not coming out. So now what we need to do is modify the quill to take our new nut. Okay, so now what we want to do is we want to bore this out to our 700 thousandths size for a nut, that diameter there, so we can put this on. Now we want to get rid of all these threads, and there's about 1 inch of threads in there, so we got to go at least that deep. I'm just going to take my time and go slow here. I would like to get a stiffer boring bar in there, but this is the only one I have that's small enough to get in there at the moment. be somewhere around 690. Okay. She's nice and tight in there. Now, I'm just gonna break that edge real quick. Okay, and now we're just going to clean this with some acetone, and we're going to Loctite that sucker right in there. Okay, so now we got everything together. This is the next day. I let the Loctite and everything dry overnight. So this nut is Loctited into place. Now you saw it was a really good fit in there, just enough room to give the Loctite a place to flow in there so that it could harden and basically permanently attach this. Now this is the way I chose to do it, because it's relatively easy to do at home, and I've actually had good luck doing things like this. This is actually the system that's holding my crossfeed screws together on both lathes, and have been doing it for 5 years. Now you got a couple of options here. You can go a little bit deeper. Like I said, I went in 3/8 of an inch. You can go a little deeper than that. It'll give more of a purchase. The only problem is you have to thread this deeper, which is very annoying. The other thing that you can do too, if you want to try to do it, I figured it would be more of a hassle than anything. But you can just bore this out that 3/8 of an inch depth, right? And leave the threads in here still. And then twist this around and put the screw in and basically time the threads together. So you connect this thread to that thread. It's going to be kind of hard to do, but you will be able to do it. And then you can Loctite that in place, and hopefully not Loctite your screw in place too. But this is the way I chose to do it. Another way to do it would be to silver solder this into place. If you want to permanently attach that, it's all up to you. There's no real good place to put a pin in here, so that's why we didn't go that route. So this is all together. Our lead screw here is pinned and Loctited in place. That's going nowhere. I decided to put a pin in this one because it was very simple just to cross drill it and put a pin. So that going to there. There goes our tailstock barrel extension. Now the other thing that you'll have too is there is a oil hole here. More than likely this is not going to line up vertically when you do this. The way to get it vertically is you'd have to just cut off a little bit of the threads on this or on this so it starts in a different spot, and just experiment until you get it vertical, or you can just cut it or just drill yourself a new hole if you need to. So those are in there hand tight, and our screw goes in and out like it should. And where we come off the screw is right at the beginning of that little groove on the top there, which is where we wanted it. Okay, one thing I do have to say is I measured this, the actual measurements of everything that I had here, I did off of my tooling that I use. So if you look, there's a piece of tanged tooling, okay? It goes in, and right at that 0 is where I'm actually impacting the screw, and a little bit of force, boom, it ejects, okay? Now, the problem here is the smallest piece of tooling that I have is my live center that does not have a tang on it, okay? So, when I push that in, when I pull this back, I'm at the 0. I'm not hitting it, obviously, because this is shorter than the piece of tang tooling. This barrel will start to go inside, the quill will start to go inside the barrel, and right at the end here is where I'm hitting. Now I only have about a quarter turn on the hand wheel, a quarter to a third turn on the hand wheel here. Let me just show you. So, let me get you in here a little bit better. So, let's set that in there, okay? So right there I'm starting to hit, you can see there, and I only have this much of a turn before that quill bottoms out, but I still eject, okay? Now, if you do this and you have a problem, this is the smallest piece of taper tooling that I own, or with the shortest taper on it. If you have a problem with a tool not reliably ejecting, you got basically 3 options you can do. Option number 1 is you can drill the end here and tap in a socket head cap screw. That just extends it just enough to be able to eject your tool. You can also do the same with the actual threaded portion of the screw. So just drill and tap the end for a socket head cap screw. That'll extend it a little bit. Or you can just take this off and go to that Acme nut that we made and just shave a little bit off the end, enough to get your tool to eject. Now in my case here, this quill goes a little bit into the barrel here. You can see it right here for it to eject, but that's perfectly fine, for me at least. And the tang tooling ejects reliably right at that 0 mark. So depends on how you guys want to make it. You can adjust some of the measurements if you want, but this works perfectly fine for me. So now all we need to do, and it'll be on a future videos, is see if we can continue these markings down the barrel there, or down the quill there, and make it all nice. But worthwhile modification, not too bad to do, and as long as you can measure accurately, it's well within your capability.